Oxidation numbers. As I said, this comes out of the next chapter, but I'm going to go ahead and jump to it because you need to know it in order to do the nomenclature. Big name for naming. Also, the rules will be posted and there will be extra problems. So, let's start through them. There are rules associated with oxidation numbers. Do you have to memorize them? No, once you've worked a number of oxidation number problems, you'll have some in mastering. They're a bunch at the back of the book. And then, as I said, I posted extra problems. You can do them. Remember, the problems in the text are not in chapter 2. They're in the next chapter. They're maybe in 4, but I think they're in 3. And as I said, the reason why is you need them in order to name. So I'm not sure why they don't do them before, but we're going to do them before, and the rules are posted. So the first rule is the oxidation number of an element in its elemental form is 0. So if I have silver, no charge, then it is 0. If I have a diatomic like H2, it's 0 as well because that is the elemental form. Okay? The oxidation of a monoatomic ion is the same as its charge. That means that A plus is 1 plus. Calcium 2 plus would be 2 plus, and aluminum would be 3 plus. Chloride would be 1 minus, etc. So monoatomic means one atom. So those are whatever the compound is. In binary compounds, binary means 2 species. Binary means 2, but we're going with 2 species. The more electronegative element is assigned a negative oxidation number. We haven't done electronegative. So basically, first one listed is positive. Second one listed is negative when you're talking about 2 species. So remember before when I told you we did ions, the cation would be first, the anion is second. If you have a compound like HCl that is non-metals, then this one's going to be positive and this one's going to be negative. Okay, so basically you list the positive species first, whether it's a positive ion or as a positive oxidation number. Now, the sum of oxidation numbers equals 0 for a neutral compound and is equal to the overall charge for an ionic species. Okay, so if we have calcium oxide, okay, calcium is 2 plus, oxygen is 2 minus, so this has to equal 0. If I have this species here, then chlorine, oxygen is going to be 2 minus, and the whole thing has to equal whatever the charge is, so the chlorine has to be 3 plus here. Okay, so I'm jumping ahead a little bit, but I have to show you what we're doing. So that would be minus. If we had PO4, 3 minus, then the phosphorus plus the oxygen has to equal 3 minus. We're going to work a whole bunch of these, so don't freak. The oxidation number of fluoride in any compound is 1 minus. Fluoride, you're going to find out, is not, it doesn't like to play well with electrons. It wants them. So it will always be 1 minus. In compounds, elements of group 1A have oxidation numbers. These are the alkali metals. This is the family that starts with lithium, then sodium, potassium, etc. on down. That's group 1. So they will always be 1 plus. They can't be anything else. Group 2, the alkaline earth species, metals, have to have an oxidation number of 2 plus. So if you look at them, it's beryllium, magnesium, calcium, etc. Okay? And remember, there are always a few exceptions, but you have to go with the general rule. They're all going to be 2 plus. That's all they can be. All right, elements of group 7A, those are the halogens. That's fluorine, chlorine, bromine, iodine, etc. Will have 1 minus when they are combined with a less electronegative species. That's That's what that is. So less electronegative species means metals. So if you combine halogens with metals, the halogens are going to be negative. If you combine halogens with nonmetals, then they may be positive. Okay? But if they're listed last, then they're negative. All right, the oxidation number of oxygen in any compound is 2 minus, except in 3 cases. First off, when it's in combination with fluoride, because we said fluoride must be negative 1. If fluoride has to be negative 1, then oxygen has to be positive, because you cannot have 2 negatives in a compound to make a neutral compound, right? Okay, in peroxides, oxygen is 1 minus in the form of O2, 2 minus. This only occurs with group 1 and group 2. Okay, so for example, if you have sodium oxide, that's sodium where oxygen is 2 minus here. If oxygen is only 1 minus, then you only have 1 sodium. Okay, but it's in the form of O2, so you'd have to have 2 here. So because sodium has to be 1 plus, oxygen would have to be 1 minus. And that only occurs with group 1 and group 2. Now there's an even weirder form that is superoxides, and this only occurs with these groups here. So if you have rubidium 2 oxide, that's oxygen is 2 minus. Rubidium 2 oxygen 2, oxygen is 1 minus here. If you have rubidium O2, then oxygen is minus 1/2 here. So the trick is that since group 1 and group 2 are non-negotiable, then you can tell the oxygen from that. So if oxygen is combined with anything in group 1 or 2, you might want to double check it to see if it's a peroxide or a superoxide. Okay? We're going to work problems, so hang with me. Oxidation number of hydrogen in compounds is 1 minus in compounds with less an electronegative species, metals. Remember, M is metals. Okay, it's going to be positive when it's in combination with more electronegative species, which are the nonmetals. Okay, so that means that if you were to take cobalt, I'm not sure how I ended up with nitrogen there, but cobalt hydride, that would be CO2. Whereas if it's combined with oxygen, it's going to be H2O. So remember, this is your nonmetal, and this is your metal. Okay? So as long as we keep those rules in mind as we work the problems, we can work the problems designated here. And I will work these through. And remember, there are extra videos of these posted so that you can look at additional problems. If you need a few more, let me know. And remember, there are extra problems posted. So let's look at this. As you do oxidation numbers, I want the oxidation number of each element. I don't care how many of each atom is present. I only care about each atom. This works, for example, is what's the ticket price to go to a movie? All right. Now, I want to use whole numbers. So let's go with $5. And yes, I know I'd go to those movies too. But if each ticket is $5, but there are 4 of you, then you need $20. But that doesn't change the price of the ticket. So that's what I'm talking about here. So if you have 1 oxygen, it's 2 minus. If you have 3 oxygens, it's 2 minus times 3, which is 6 minus. But I want to know the 2 minus, not the 6 minus. So here I've only got sulfur, and sulfur 8. That's the oxidation number is 0, because remember, this is the elemental form of sulfur. So remember, every species in its elemental form is 0. So here we have mercury and we have chloride. Okay, so I'm going to work them off to the side here. I may kind of go over space-wise, but when I look at it and I'm like, which one do I know about? Well, I know chloride is 1 minus. And if chloride is 1 minus and there are 2 of them, then the total charge is 2 minus. This is a neutral species, so it has to equal 0, which means that the mercury has to be 2 plus, but there are 2 of them, so 2 plus divided by 2, each mercury is 1 plus. Okay? When you have more than one atom present, you will only have one negative. So we have magnesium, phosphorus, and oxygen. One of those will be negative. The rest of them are going to be positive. And since the last one listed is always negative, it's going to be oxygen. But, so when we look at it and we say, well, wait a minute, we know that phosphorus, if it was negative, would be 3 minus. But we know it has to be positive, so we don't know what it is. But according to our rules, group 2 has to be 2 plus. Oxygen has to be 2 minus, except in combination with fluorine in group 1. And it is with group 2, but it's also with phosphorus, so that negates the binary. So if we look at it, and I'm going to do it over here, so magnesium 2, phosphorus 2, O7, then we know that if each magnesium is 2 plus, then the total charge here is 4 plus. Each oxygen is 2 minus, so the total charge here is 14 minus. This has to equal 0 because this is a neutral compound. So what number is needed? 4 plus 14 minus. So that means that the phosphorus has to be 10 plus total, but there are 2 of them. So each phosphorus is going to be 5 plus. So when you work it out, you always know 2 out of 3. So on this one, we have chlorine and we have oxygen. So we have ClO4 minus. Now, again, oxygen we know is 2 minus. Chlorine is 1 minus when it's in combination with a less electronegative species, aka a metal. But since it's listed here, it has to be positive. So what is it? Well, when you look at it, there are 4 oxygens, so that means that we have 8 minus here. There's a charge on this species has to be equal to 1 minus, so therefore the missing number here is 7 plus 8 minus gives us 1 minus. So we put it in there. Nitrogen here, wait, that's a diatomic. This is a diatomic, so we have to put it in. Now, I should have said this to begin with. You may want to work these and then come back and look at it, or you may want to look these through because we've got a bunch more to work. All right, so here we go. We have oxygen, we have potassium. So I'm going to do this one here. So K2O2. Well, some of you are going to want to start off with oxygen is 2 minus. Well, if oxygen is 2 minus, then that'd be 4 minus, which means that potassium would have to be 4 plus divided by 2 would be 2 plus. Well, wait a minute. Potassium can't be 2 plus. So this is probably going to be one of those peroxide critters. So let's do it the other way. So let me rewrite it. So potassium is 1 plus. There are 2 of them. That's 2 minus. So that means this is equal to 0. Whoops, 2 plus. So the oxygen has to be 2 minus divided by 1. So that makes the oxygen 1 minus. So yes, that is a peroxide. Okay. Nitrogen and oxygen is 1 plus. Oxygen is 2 minus. We need nitrogen because there's only one of them. It's got to equal to 1 plus. So nitrogen has to be 3 plus. So nitrogen is 3 plus. Oxygen is 2 minus. Notice each time I'm doing this, I'm doing it per atom. I don't care what the overall molecule is. Now here's another one that's 3 atoms, which means only one of them is negative. And again, you work it out from what you know, Le2, tungsten 2, oxygen 7. So we know that oxygen is 2 minus. There are 7 of them, so that's 14 minus. This is a neutral species, so we're looking at 0. Both of these can't be unknown. This one's known times 2, so this is 2 plus. So what's missing is 2 plus 14 minus is 12 minus. So we need 12 plus to counteract it. We have 2 tungstens, so that would be each one is 6 plus. If we had 3, that'd be 12 divided by 3, would be 4 plus. So it's 2 plus. No, I can't even read my own writing. It's 1 plus, 6 plus, and 2 minus. Notice that this is the rule we're going for. Okay, and as I said, well, I've got additional ones for oxidation numbers and for naming, which we'll get to in a minute. But one other thing you need to know is you need to memorize the polyatomics for the nomenclature. And I would recommend you go ahead and start this as soon as possible. There are a couple interesting things that I want you to look at. We've got some little asterisks. This one is got a little asterisk in it. And notice we have nitrate and nitrite. Remember when I started that I said spelling was optional, except we're at the except, because in the case of naming nitrite, ITE is different than nitrate, ATE. And because what that indicates is the number of oxygens. So the 8 is always the higher oxidation number, which translates to more oxygens. So this one's nitrate. And so if you memorize the fact that nitrate is NO3 minus, then you automatically know that nitrite is NO2. You'll see this in nitrate, nitrite, sulfate, sulfite. Carbonate is fine. Phosphate. You can actually also have phosphite. That's phosphite. Because it has one less oxygen. The main group are the halogens right here. And you can do this with bromine and iodine as well. Can't do with fluoride. But you start with the 8 is 3. Per means one more. So per 8 is 4. Ite is 2. Hypo is like hypoactive, which is less, one less. So it's 1. So we could do this with any of the other species. So if I did IO2 minus, that is iodite, ion. Okay. Some of them are polyatomics that are all nonmetals. That would be acetate and ammonium. Ammonium is the only positive polyatomic. The rest of them are all negative. Chromate has 1 chromium. Dichromate has 2. We actually did the peroxide earlier. You have permanganate, which is a common one that you need to know. We'll actually go over this rule here when we get to the nomenclature. I throw it in both places so that you can look at it and start to see what's going on. But you want to go ahead and start memorizing this list. The other one you're going to need to memorize, and I'll go ahead and post both of these at the beginning, are the 4 that are circled in blue here, because those are polyvalent. That means that they can have more than one oxidation number. Those are the only 4 you're responsible with, because a lot of them have a lot more. And then some of them only have one charge. If you look, these are all transition metals, and a few of them only have 1 charge. That's actually particular and comes into play in the nomenclature, but the only 3 you're responsible for are the silver, zinc, and cadmium. If you look on your periodic table, you'll notice that they're at the end of the transition metals. This one is zinc, this one's cadmium, and this one is silver. And it's an easy thing to remember if you look at it on the periodic table. But you're going to need these when you do nomenclature. We'll get to this, but just like ite was lower than 8, ic means the highest oxidation number, us means the lowest. So this is ferrous, ferric, cuprous, cupric, stannous, stannic, plumbous, plumbic. Okay? And so on those, spelling is critical. Okay? So now that you've got the basic oxidation rules, you know how to determine the oxidation numbers associated with a compound, then we can go into naming, and that will be the next section, and I think it's the last in this chapter, but I'm not sure, so follow along.